The Pacific Ocean. Objectives. After attending this lesson, the learner should be able to comprehend about the geographic setting of the Pacific Ocean, its dimension, associated water masses, morphological features of the ocean floor, very significant conditions of the ocean, sediments, marine life, marine pollution, and other hazards. In addition, the user should be able to understand the importance of the Pacific in the context of global activities, including the historical oceanographic explorations. Introduction. The world's oceanic water masses occupy about 97% of the hydrosphere. The remaining 3% is frozen in the form of ice caps and distributed in the lakes, rivers, subsurface aquifer, and as water vapor. The seas and oceans cover about 70% of the surface of the Earth, which is equal to 361.1 million square kilometers in area. One water body as a whole. Oceanic water masses are fully connected and interlinked with each other. If we physically look at these, there is only one water mass existing in the world. The presence of various continents divide the world's water mass into 5 major oceans. They are the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, the Arctic Ocean, and the Antarctic Ocean. Water tentacles. Each one of these large oceans include many smaller water bodies as seas, gulfs, or bays and straits. Among these, the Pacific Ocean is the largest and the deepest ocean in the world. Understanding of the oceanography of the Pacific is an interesting topic. Geographic setting. The term Pacific is derived from the Latin term mare pacificum, which means peaceful sea. Geographically, the Pacific Ocean alone covers about 32% of the Earth's surface. The surface area of the Pacific Ocean is greater than that of all land areas put together. The Pacific extends from the Arctic of the North Pole to the Antarctic regions of the South Pole. This ocean is bounded by the North and South America on the east. It is bounded by Asia, Japan, Australia, and New Zealand on the west. The Pacific Ocean is known for its enormous biological resources and geological features. Links with other water masses. The Pacific Ocean is linked with the other water masses through straits and passages. It is linked with the Arctic Ocean through the Bering Strait. It is linked with the Atlantic Ocean through the Drake Passage at the southern end of South America, Straits of Magellan, and finally through the Panama Canal. The Pacific Ocean is linked with the Indian Ocean through the passages like Malay Archipelago, Torres Strait existing between Australia and Papua New Guinea. Dimension. The Pacific is a very vast ocean covering individually about 165 million square kilometers. Along with its other marginal seas, it covers an area of about 180 million square kilometers. Its maximum length along the north-south direction is about 14,500 kilometers. Its maximum width along the east-west direction is about 17,700 kilometers. That is seen between the Isthmus of Panama and the Malay Peninsula. It extends approximately 15,500 kilometers from the Bering Sea in the North Pole to the southern tip of the globe. The Pacific has its greatest east-west width at about 5 degrees north latitude. It stretches for about 19,800 kilometers from Indonesia to the coast of Colombia and Peru. This distance itself is halfway across the world. The Equator and International Dateline. The Equator subdivides the Pacific Ocean into the North Pacific Ocean and South Pacific Ocean. The Pacific Ocean is a historically significant part in the world. The Pacific plays its role in classifying the world time zones. The 180-degree meridian passes through the Pacific. It is called as the International Dateline. It is where each day begins. Depth. The Pacific Ocean is the deepest ocean in the world. The mean depth is 4,280 meters. Its greatest depth lies within the Mariana Trench and the Japan Trenches. These two are the world's deepest trenches, reaching a depth of more than 10 kilometers. The Mariana Trench lies in the western North Pacific Ocean with a depth of 10,911 meters below sea level. The deepest parts of the Pacific are also very closer to the shores of land masses. They include the Japan and Kuril trenches, which border the island chains of the western Pacific. Principal arms. The water tentacles of the Pacific are called as oceanic arms. The principal arms of the Pacific Ocean are the Bering Sea in the north, the Gulf of California in the east, the Ross Sea in the south, and the Sea of Okhotsk, the Sea of Japan, and the Yellow Sea, East China Sea, South China Sea, Philippine Sea, Coral Sea, and Tasman Sea in the west. Volume of water. The total volume of all oceanic waters in the globe is about 1,370 million cubic kilometers, out of which the volume of water exists in the Pacific Ocean is about 714.410 million cubic kilometers. This is about 53% of the total volume of water of all the oceans put together. Much of the fresh water to the Pacific also comes from a few large rivers like the Columbia of North America and the Huanghe, Chang, Yangtze of China. Historical explorations. About 3,000 years ago, seafarers started their voyages in the oceanic world. The famous and remarkable ancient explorations were started by the Greeks, Chinese, Europeans, Romans, Asians, the British, and the Portuguese. The Portuguese explorer, Ferdinand Magellan, named this great oceanic watermass as the Pacific Ocean. Explorations and migrations. The ocean explorations had several reasons to the study of the Pacific Ocean in depth. The early migrants have crossed the long distances of the open Pacific Ocean using primitive boats. The islands of the South and West Pacific were populated by migrants. Most of them were from the Asia. The European travelers, including Marco Polo, had reported an ocean off Asia in the late 15th century. Some trading ships had also sailed around Africa to the western rim of the Pacific during this time. 16th century explorations. The true recognition of the Pacific as a distinct ocean from that of the Atlantic Ocean came after Balboa's sighting of its eastern shore during the year 1513. Magellan's crossing of the Philippines during the year 1520-21 initiated a series of explorations. The notable ones were the explorations of Drake, Tasman, Dampier, Cook, Bering, and Vancouver. These went up to the end of the 18th century. All these explorations had mainly disclosed the nature of the coastline and the major islands of the Pacific to the other parts of the world. In the 16th century, the supremacy in the Pacific region was shared by both Spain and Portugal. After 17th century, the English and the Dutch have established the footholds in the Pacific during the 17th century. The France and Russia have done some expeditions during the 18th century. The people of Germany, Japan, and the United States have done their works during the 19th century. The Pacific Ocean has its own history in the history of the world. It is because of these world-famous voyages and explorations of Pacific Islanders, it was possible to acquire all practical knowledge about oceanography over these years. Ferdinand Magellan. In 1494, the line of demarcation was done to establish the boundary between the Atlantic and Pacific Oceans. The Portuguese and the Spanish together explored the vastness of the Pacific Ocean over a period of time. In 1520, Ferdinand Magellan conducted an expedition with 3 ships. They sailed out of the stormy passage of the strait at the southern tip of South America into the Pacific Ocean. It was Magellan who named the Pacific as a peaceful, calm, quiet ocean. Magellan's voyages were followed by several voyages from the western coasts. Other explorers. The Dutch explorations are also very notable ones. Dutch explorers looked mainly for profit in the Pacific Ocean for its trade. The British also did notable explorations of the Pacific. In 1765, Byron sailed into the Pacific Ocean and declared that 2 northern islands were belonging to the British. They are the Tuamotu Islands and the Puka Puka in the northern Cook Islands. In 1768, Captain James Cook, 1728 to 1779, sailed on his first voyage to the Pacific. Cook proved that the 2 islands of New Zealand were definitely not part of some larger southern continent. They are independent. Inputs from the explorations. The people of the ancient explorations gave the details of the major oceanic currents, prevailing wind patterns, and the other features of the Pacific. It was due to these voyagers we could get the details of equatorial countercurrent, the Great Northern Whirl, the Great Southern Whirl, and forecasting of all wind seasons. Crustal plate. According to the theory of plate tectonics, the Earth's outer shell consists of huge, rigid plates. The plates are of 2 types, as oceanic plates and continental plate. Although continental plates are located under the continents, they usually extend into the ocean as well. Only small continental plates, like the Turkish Aegean plate, do not extend into the ocean. Oceanic plates are located under the oceans. There are 3 major oceanic plates. The smallest of the 3, the Cocos plate, is located west of the Central American. The largest plate is the Pacific plate. It spans over most of the Pacific Ocean. The third one is the Nazca plate. It is located west of South America. Plate tectonics. The plates were initially together. The plates move away from one another along the divergent plate boundaries. At the same time, they must move toward one another along the convergent plate boundaries elsewhere. As the plates move, they carry the ocean floor and the continents with them. The relative movement of 2 neighboring plates is generally about 1 to 10 centimeters a year. When 2 plates collide with each other, one plate may pile up against the other. This created the underwater mountains. Sometimes one plate may be drawn down into the mantle under another plate. Such an action produces deep oceanic trenches and generates volcanic eruptions. Earthquakes may also occur near these plate boundaries. Impacts. Different movements of the plates have different effects on the ocean bottom. Seafloor spreading and the formation of new seafloors occur where the plates move apart. The mid-ocean ridges also mark the existence of such zones. The Pacific Ocean is currently shrinking due to the theory of plate tectonics. It shrinks by roughly an inch per year, 2 to 3 centimeters per year on 3 sides. It amounts to an average of 0.5 square kilometers a year. The ocean is shrinking. Profile of the ocean floor. The ocean floor is a region of spectacular morphology and contrasting relief features. Beneath the sea, there are broad plains, towering mountain chains, undersea volcanoes, deep trenches, and valleys. The morphology of the Pacific consists of a vast continental shelf, continental slope, and a deep ocean basin. Continental shelf. The continental shelf is the submerged land at the edge of the continents. It begins at the shoreline and gently slopes underwater to an average depth of about 120 to 130 meters. The width of the continental shelf averages 75 kilometers. The edge of the continental shelf occurs and extends to a depth of 20 to 550 meters, averaging 130 meters. The continental shelves of the Pacific consist of huge deposits of sand, mud, and gravels. There is a vast thickness of consolidated sedimentary rocks overlying crystalline rocks. The edge of the shelf is called as the shelf break. It is characterized by an abrupt increase in the slope to an average of about 4 degrees. Continental slope. The continental shelf is followed by the continental slope. The slope is much steeper than the shelf and plunges to a depth of about 3.6 kilometers. The continental slope forms the sides of the continents. The width ranges from 20 to 100 kilometers. In many places, deep underwater canyons gash the slope. One of the most surprising findings of the early oceanographers was that the deepest parts of the oceans are not at the centers. They are quite close to the margins of continents, particularly in the Pacific Ocean. The continental slope of the Pacific is very close to the coastlines in almost all the surrounding countries of the Pacific. Submarine canyons. A lot of submarine canyons are found cutting across the shelf and slope. They are often extending from the mouths of the terrestrial rivers. The valleys may be 12 meters deep. The maximum depth may go up to 300 meters. The following are the notable submarine canyons of the Pacific Ocean: Bering Canyon, Monterey Canyon, Navarin Canyon, Pribilof Canyon, Scripps Canyon, and Zemchug Canyon. Deep ocean floor. The deep ocean floor begins at the seaward edge of the continental slope and rise. Deep-sea peaks, valleys, and plains lie beyond the continental margin. The thickness of sediments in the oceans averages about 450 meters. The sediment cover in the Pacific Ocean basin ranges from 300 to 600 meters. The deep-sea sediments can reveal much about the Earth's history of the last 200 million years. They show the evidences for various processes, including seafloor spreading, the history of ocean life, the behavior of Earth's magnetic field, the changes in the oceanic currents, and paleoclimate. The ocean basins are transient features over geologic time, changing shape and depth while the process of plate tectonics occurs. Abyssal plains and hills. An abyssal plain is an underwater plain on the deep ocean floor. It is usually found at depths from 3,000 meters to 6,000 meters. The abyssal plains are among the flattest, smoothest, and least explored regions on Earth. The abyssal plains occupy a significant portion of the deep ocean basin. The abyssal plains cover nearly 75% of the Pacific Ocean floors. They are formed by the deposition of fine sediment carried by turbidity currents. These sediments have covered and smoothed out the irregularities in the morphology of the ocean floor. The flatness of these plains is due to the result of the accumulation of a blanket of sediments up to 5 kilometers in thickness. These overlie the basaltic rocks of the oceanic crust. The thick sediment deposits extend up to a distance of about 1,000 kilometers inside the sea from the slope. Ring of Fire. The Pacific is the oldest of the existing ocean basins. Its oldest rocks have been dated at about 200 million years. The Pacific Basin is referred to as the Ring of Fire due to intense earthquake and volcanic activity occurring near areas of tectonic plate subduction. Mid-ocean ridges. The mid-ocean ridges form a chief feature of the deep ocean basin. The ridges consist of a chain of mountains that runs about 60,000 kilometers through the three major oceans. Scientists discovered the mountain chain independently in each ocean and gave it different names, including Mid-Atlantic Ridge, East Pacific Rise, and Mid-Indian Ridge. Most mountains of the mid-ocean ridges stand about 1,500 meters above the seafloor. Deep valleys cut across the ridges in many places, producing a rugged, fractured surface. Frequent volcanic activity occurs along such central valleys. The Pacific rises. The East Pacific Rise is a mid-ocean ridge. It extends from the Gulf of California to a point west of the southern tip of South America. It rises to an elevation of 2,130 meters above the ocean floor. Along the East Pacific Rise, molten rocky magma upwells from the Earth's mantle, adding crust to the plates on each side of the rise. Deep ocean trenches. An ocean trench is a long, deep depression in the ocean floor. These trenches are one of the most striking features of the Pacific floor. Deep-sea trenches generally lie seaward, off and parallel to the island arcs or mountain ranges of the continental margins. Trenches virtually encircle the rim of the Pacific basin. The trenches have lengths of thousands of kilometers. They are generally of hundreds of kilometers in width. They extend up to 3 to 4 kilometers deeper as valleys within the surrounding ocean floor. Trenches of the Pacific Ocean. The notable trenches of the Pacific Ocean are Mariana Trench, Tonga Trench, Philippine Trench, Kurit-Kamchatka Trench, Kermadec Trench, Izu-Ogasawara Trench, Japan Trench, Yap Trench, Peru-Chile Trench, Aleutian Trench, Middle America Trench, Puisegur Trench, Whittiers Trench, and Ryukyu Trench. Seamounts. A seamount is an underwater mountain rising from the ocean seafloor. It does not reach to the oceanic water's surface or sea level. They do not form islands. These are typically formed from extinct volcanoes that rise abruptly and are usually found rising from the seafloor to an elevation of 1,000 to 4,000 meters. The smaller submarine volcanoes are called sea knolls. The Pacific Ocean contains several long seamount chains. They are formed by hotspot volcanism. These include the two major seamount chains as the Hawaiian Emperor Seamount Chain and the Louisville Seamount Chain. Bathymetric profiles from the Pacific have shown that there are about 10,000 seamounts existing with more than 1 kilometer elevation. Guyots. The flat-topped seamounts are called as guyots. They are named after Arnold Henry Guyot, 1807 to 1884, the Swiss-born American geologist and geographer. Guyots are isolated submarine volcanic mountains with a flat summit of more than 200 meters below the sea surface. The flat tops may have diameters greater than 10 kilometers. Guyots are most abundant in the Pacific Ocean. Their summits lie 1,000 to 2,000 meters below sea level. Icebergs. An iceberg is a large piece of frozen ice that has broken off from a glacier or an ice shelf and is floating freely in open water. Icebergs generally range from 1 to 75 meters above sea level and weigh 1 lakh to 2 lakh metric tons. The term iceberg most likely got originated from the Dutch term Ijsberg, which means ice mountain. There are very few such features in the Pacific, as they are mostly in the North and Pacific, nearer to the poles. Active volcanoes. There are active volcanoes in every part of the world. There are about 1,500 active volcanoes. Many of them are located in the Pacific Ocean. The Pacific Rim's Ring of Fire is an arc around the Pacific Ocean where there are 400 and more volcanoes. The Ring of Fire is comprised of over 75% of the world's active and dormant volcanoes. The ring is about 40,000 kilometers long. Islands or island arcs. The Pacific contains about 25,000 islands. Many of them are concentrated in the south and west. It is more than the total number in the rest of the world's oceans combined. The majority of these islands are found south of the equator. Most of the Pacific islands lying south of the Tropic of Cancer are collectively referred to as Oceania. In the southwestern corner of the Pacific lie the islands of Melanesia, dominated by New Guinea. Other important island groups of Melanesia include the Bismarck Archipelago, Fiji, New Caledonia, the Solomon Islands, and Vanuatu. Types of islands. Islands in the Pacific Ocean are of four basic types as continental islands, high islands, coral reefs, and uplifted coral platforms. Continental islands lie outside the andesite line and include New Guinea, the islands of New Zealand, and the Philippines. Some of these islands are structurally associated with nearby continents. High islands are of volcanic in origin and may contain active volcanoes. Among these are the Bougainville, Hawaii, and the Solomon Islands. The third and fourth types of islands are both originated due to coral growth. Coral reefs are low-lying underwater structures that have built up on the basaltic lava flows of the ocean's surfaces. One of the most dramatic is the Great Barrier Reef of the northeastern Australia. Sedimentation. The distribution of sediments in the oceans is controlled by 5 primary factors: age of the underlying crust, tectonic history of the ocean crust, structural trends in basement, nature and location of sediment source, and nature of the sedimentary processes delivering sediments to the basins. Water masses and temperature. The volume of the Pacific Ocean is approximately 622 million cubic kilometers. Water temperatures in the Pacific vary from freezing in the poleward areas to about 30 degrees centigrade, 86 degrees Fahrenheit near the equator. Salinity also varies with reference to latitudes. The water near the equator is less salty than the one found in the mid-latitudes because of abundant equatorial precipitation throughout the year. Because the vast majority of the world's ocean's volume, the mean temperature of seawater is low. About 75% of the ocean's volume has a temperature from 0 degrees to 5 degrees centigrade. The same percentage falls within a salinity range between 34 to 35 parts per thousand. The surface temperatures can range from below freezing point near the poles to 35 degrees centigrade in restricted tropical seas, while the salinity can vary from 10 to 41 parts per thousand. The western tropical Pacific has the warmest surface waters. Salinity. The salinity of seawater, denoted by the symbol 0/00, is defined as the number of grams of salt contained in 1000 grams of seawater. Seawater is about 3.49% salt solution. The more saline, the denser the seawater. As the range of salt concentration in the ocean varies from about 3.2 to 3.8%, oceanographers refer to salt content as salinity. 3 major factors influence salinity or salt concentration in Pacific Ocean waters. They are precipitation, evaporation, and winds. Around the equator, where there is large amounts of rainfall, the surface water salinity rarely exceeds 34 parts per thousand. The lowest salinity in water occurs in the extreme northern regions of the Pacific near the Bering Sea. Here, the salt concentrations are often less than 32 parts per thousand. Density. Ocean water gets more dense as temperature goes down. So, the colder the water, the more dense it is. Increasing salinity also increases the density of seawater. The density of ocean water is rarely measured directly. The measured density values are on the average to plus or minus 4.3 into 10 to the power of minus 6 gram centimeter to the power of minus 3. The density of water in the Pacific were found to be plus or minus 3.8 to plus or minus 3.0 into 10 to the power of minus 6 gram centimeter to the power of minus 3 from 0 to 490 meter depth zones, 12.5 plus or minus 4.2 into 10 to the power of minus 6 gram centimeter to the power of minus 3 from 490 to 1000 meter depth zones, and 17.6 plus or minus 2.6 into 10 to the power of minus 6 grams centimeter to the power of minus 3 from 1000 to 5834 meter depth zones. In the deep waters, the measured values of density are equal to 6 into 10 to the power of minus 6 gram centimeter to the power of minus 3. Climate of the Pacific. The climate of the Pacific is greatly influenced by the following: planetary air pressure systems, trade winds and westerly winds, tropical cyclones, hurricanes and typhoons, continental influences, and the monsoonal, a rainy season. Effects on climate. The planetary air pressure systems and resultant wind patterns exhibit remarkable uniformity in the climate of the south and the east. The trade winds and westerly winds are well-developed patterns modified by seasonal fluctuations. Tropical cyclones or hurricanes may form south of Mexico from June to October and affect Mexico and Central America. The continental influences cause climatic uniformity to be much less pronounced in the eastern and western regions at the same latitude in the North Pacific Ocean. The Western Pacific is monsoonal, with a rainy season occurring during the summer months, when moisture-laden winds blow from the ocean over the land. The tropical cyclones or typhoons may strike Southeast and East Asia from May to December. Water circulation and ocean currents. The waters of the Pacific Ocean move constantly. Two types of circulation create the currents in the ocean. They are wind-driven circulation and thermohaline circulation. Wind-driven circulation results from the wind blowing on the ocean surface. Wind-driven currents move in enormous circular patterns called gyres. Surface circulation. The surface circulation of the oceans is intimately tied to the prevailing wind circulation of the atmosphere. Major circulation of water in these gyres is clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. The circulation of ocean waters is vitally important in dispersing heat energy around the globe. In general, heat flows toward the poles in the surface currents, while the displaced cold water flows toward the equator in deeper ocean layers. Thermohaline circulation. Thermohaline circulation refers to the deep water circulation of the oceans. It is primarily caused by differences in density between the waters of different regions. Wind systems. There are two major wind systems driving the waters of the Pacific Ocean. They are the westerlies and the trade winds. The westerlies lie about 40 to 50 degree latitude in both the hemispheres. They are called as the roaring forties, and the trade winds come from the east, which dominate in the region between 20 degree north and 20 degrees south. Oceanic currents. Huge whirls formed by the major ocean currents are found roughly north and south of the equator. The chief currents of the North Pacific, beginning at the equator, are the North Equatorial Current, Kuroshio Japan Current, North Pacific Current or Drift, and California Current. The South Equatorial Current and the Antarctic Circumpolar Current both are belonging to the South Pacific Currents. Ocean waves. Scientists have discovered waves that rise up to be taller than some skyscrapers. The ocean waves, which are also known as internal waves, form at the boundary between two layers of water with different densities in a deep ocean trench in the South Pacific Ocean. The highest waves are found to be as much as 15 to 20 meters. Ecological zones. The first appearance of life on the Earth is thought to have occurred in the oceans in about 2 or 3 billion years ago. Biological oceanography is an important aspect of all oceans. The modern marine environment of oceanic waters is divided into two major realms as the Benthic Realm and the Pelagic Realm. These are classified based upon the ecological characteristics and marine life associated with them. The Pacific Ocean has an incredible variety of living things. These marine life ranges in size from microscopic one-celled organisms to the blue whale, which may measure up to 30 meters long. They are divided into three groups as the plankton, nekton, and the benthos. The Benthic Realm. The Benthic Realm refers to the floor of the oceans extending from the high tide line to the greatest ocean depths. The organisms that live in or on the bottom are called benthos. The Benthic Realm is subdivided on the basis of depth into the littoral zone, which extends from high tide to a depth of about 200 meters, and the deep sea realm. The benthic life forms are both sessile, attached, and motile, mobile. Some benthonic life forms live by predation. Many others live on the organic matter from the water. Some others scavenge the bottom for organic debris that are available inside. Benthonic plants can live only in the euphotic zone, the uppermost 100 to 200 meters of the ocean where sunlight penetrates. Benthonic animals live below the euphotic zone. The Pelagic region. The Pelagic realm consists of all of the ocean water covering the Benthic realm. It is divided horizontally into two zones as Neritic, fertile nearshore province, and the Oceanic province. Vertically, it is divided into the euphotic or photic zone and the aphotic, without sunlight zone. Drifting, free-floating organisms, called plankton, and organisms with poor mobile ability populate the euphotic zone. Most plankton are microscopic or near microscopic in size. Heterotrophic plankton or zooplankton are also floating animals and protozoans of the sea. Rely on the phytoplankton as food sources. Foraminifera and radiolaria are the dominant protozoans. Many juvenile forms of swimmers, such as shrimp, or bottom dwellers, such as barnacles, pass through a planktonic phase. Marine organisms capable of self-locomotion are called nektonic life forms. Fish, squid, and whales are examples of marine nekton. Marine fauna. The ocean is home to countless numbers of plants and animals. Most of the ocean's plant life requires sunlight. Many ocean plants float on the surface of ocean waters or live on the ocean floor in shallow water. These plants provide food, protection, and habitats for many marine animals. Some plants are also sources of vitamins and minerals for people. Marine life in the Pacific Ocean. Fish are the most important animals of the nekton. About 13,300 kinds of fish live in the ocean. Squids are free-swimming mollusks, animals with soft, boneless bodies that have 10 arms. Nektonic mammals include dugongs, manatees, porpoises, and whales, all of which remain in the ocean all their lives. Other marine mammals, such as sea lions, sea otters, seals, and walruses, spend time on land. The Pacific's greatest asset is its fish. The shoreline waters of the continents and the more temperate islands yield herring, salmon, sardines, snappers, swordfishes, and tuna, as well as shellfish. Marine flora. The ocean is a complex environment that is home to many types of plant species. Plants found in the ocean provide a basic source of food and shelter for marine life. The kinds of plants found in the ocean are of two basic types, as those that have roots and those that do not have any roots. Most plants need sunlight, water, and soil in order to grow. Many plants also thrive in the ocean habitat. The most famous plants are seaweed, seagrass, phytoplankton, kelp, red algae, coralline algae. Marine sediments. The thickest deposits of sediment on Earth are on the ocean floor. In the oceans, it piles up to 8 kilometers in thickness. The thickest buildup of sediments are found on the continental rises and slopes. Ocean sediments are basically small, insoluble particles of rocks, soil, volcanoes, chemicals, and organic bodies. They are delivered into the ocean from lands via rivers, streams, and lakes. These particles are of different sizes and volumes and are commonly present on the shores of oceans. Types of sediments in oceans. There are 4 major types of ocean sediments which are composed by different organic and inorganic materials. These include hydrogenous sediments, biogenous sediments, lithogenous sediments, and cosmogenous sediments. Hydrogenous sediments. Hydrogenous sediments are usually found near the hydrothermal vents where metal ions are released into the water. They combine with the silica and become a dark, metal-rich sediment. Other forms of hydrogenous sediments are manganese nodules, phosphates, carbonates, and evaporite salts and ammonia. The hydrogenous sediments are the result of chemical reactions between hydrogenous minerals of the oceans and rivers, or are simply created during the precipitation process or condensation process of the ocean's water in changing climatic conditions. Biogenous sediments. The biogenous sediments are the hard and insoluble remains of organic life on sea and land, like bone particles. The biogenous marine sediment is a kind of pelagic marine sediment. It contains remnants of living organisms, mostly plankton. The plankton that forms this sediment comes from species that have shells made of calcite and opal. For phytoplankton, the plant-like photosynthesizers, coccoliths have calcite shells and diatoms have siliceous or opal shells. Zooplankton, the animal element, produces foraminifera that have calcite shells and radiolaria composed of siliceous or opal shells. Lithogenous sediments. The lithogenous sediments are tiny particles from rocks, volcanic eruptions, metal ores, and various other natural elements. Feldspar grains are found in lithogenous marine sediment as well as lithogenous clay. Lithogenous clay is termed pelagic clay if more than 70% of it has lithogenous sediment in its dry mass. The ocean floors in the deepest parts of the Pacific Ocean are predominantly composed of lithogenous sediment. In the Central Ocean basins, the largest component of lithogenous sediment is clay. Cosmogenous sediments. The cosmogenous sediments are tiny meteorites and specks which are extraterrestrial in nature. Economic mineral resources. The exploitation of the Pacific's mineral wealth is hampered by the ocean's great depths. In shallow waters of the continental shelves off the coasts of Australia and New Zealand, petroleum and natural gas are extracted. Pearls are harvested along the coasts of Australia, Japan, Papua New Guinea, Nicaragua, Panama, and the Philippines. The mineral wealth of the ocean extends to the deep sea floor. Deposits near undersea hot springs contain copper, iron, and zinc. Mineral resources of the Pacific Ocean. The shallow continental shelves have been exploited as a source of sands and gravels. In addition, extensive deposits of petroleum-bearing sands have been exploited in offshore areas, particularly along the Gulf and California coasts of the United States and in the Persian Gulf. On the deep ocean floor, manganese nodules, formed by the precipitation of manganese oxides and other metallic salts around a nucleus of rock or shell, represent a potentially rich and extensive resource. Ocean water is processed to extract commercially valuable minerals such as salt, bromine, and magnesium. Although nearly 60 valuable chemical elements are found to have been dissolved in ocean water, most of them are in dilute concentrations. Due to this, their commercial extraction is not profitable. Commerce and shipping. The ocean has been a highway for trade since people built the first ships thousands of years ago. Today, transportation, especially of heavy and bulky products, remains an important use of the ocean. Most of the trans-Pacific sea lanes pass through the Hawaiian Islands. Since the 1950s, many of the South Pacific islands have become world-famous tourist centers. Waterways along the Pacific. Strategically important access waterways along the Pacific include the La Perouse, Tsugaru, Tsushima, Taiwan, Singapore, and Torres Straits. Ports and terminals. Ports and terminals of the Pacific Ocean are Bangkok, Thailand; Hong Kong, China; Kaohsiung, Taiwan; Los Angeles, US; Manila, Philippines; Busan, North Korea; San Francisco, USA; Seattle, USA; Shanghai, China; Singapore; Sydney, Australia; Vladivostok, Russia; Wellington, New Zealand; and Yokohama, Japan. Marine pollution. Problems of the Pacific Ocean. Marine pollution is a generic term for the harmful entry into the ocean of chemicals or particles. The Pacific is no exception to all kinds of pollutants entering into the sea. Oil is a major source of ocean pollution. Most oil pollution enters the ocean from oil spills on land or in rivers used to transport petroleum. The world's largest accidental oil spill occurred in June 1979 when an oil well blew out off the east coast of Mexico and spilled about 490 million liters of oil. Ocean dumping. Ocean dumping is yet another problem of the Pacific. The deliberate dumping of waste products into it is another major source of ocean pollution. Such products include industrial waste and sewage. Industries dump chemicals, animal and plant matter, and other pollutants. Throughout history, humans have been directly or indirectly influenced and benefited by the oceans. Hazards. The Pacific is surrounded by a zone of violent volcanic and earthquake activity. The Pacific is also subjected to frequent tropical cyclones or typhoons in southeast. Tropical cyclones or hurricanes may form south of Mexico and strike Central America and Mexico from June to October. Cyclical El Nino or La Nina phenomenon occurs in the equatorial Pacific, influencing weather in the Western Hemisphere and the Western Pacific. Ships are subjected to superstructure icing in extreme north from October to May. Persistent fog in the northern Pacific can be a maritime hazard from June to December. Most tsunamis strike land areas or bordering the Pacific Ocean. Fortunately, scientists can predict how fast a tsunami is moving and are able to warn people in its path.